time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth.
It's one small step for man, one giant leap for mankind.
Today is a day for mourning and remembering. Nancy and I are pained to the core by the tragedy of the Shuttle Challenger.
The following program may contain coarse language, adult themes, and bad attempts at humor. Listener discretion is advised.
What is President Trump's goal? What is his vision? He wants to put an American flag on Mars.
Houston, Tranquility Base here. The Eagle has landed.
Is a pretty big place. If it's just us, seems...
Okay, we're having some technical difficulties here. Hold a second, please. There we go. I am JEFF, and nothing seems to be coming through. Let me see. Check a couple things here. Okay, we got that. We got that. Okay, let's try this again. I am JEFF. What a way to start tonight's episode, let me tell you. Live radio. You can find me as A Cosmic Bard on X. This is the Lost Wanderer podcast for July 26, 2026. Produced from Listening Post Studios and simulcast on KLRN Radio. 2 weeks later, here we are again aboard the ACS Serenade as it is underway. This time, our journey begins with the machines that make every journey possible, rockets. For most of human history, reaching space was impossible. Even after it became possible, it remained the exclusive territory of superpowers willing to spend staggering amounts of money for every pound lifted from the ground. Rockets were not considered infrastructure. They were more national monuments that happened to explode in an upward trajectory. A newly published study attempted to calculate how much this has changed. Researchers assembled the largest standardized collection of launch data yet produced, more than 4,400 launches, over 330 different rocket configurations, and 16 spacefaring nations or regions covering everything sent skyward between 1960 and 2025. And once they adjusted everything into 2024 dollars, they found that launching 1 kilogram, or about 2.2 pounds in Freedom units, into orbit cost an average of $87,000 in 1960. By 2025, that average had fallen to a mere $3,868. That reduction is approximately 96%. Once again, putting this into Freedom units, because this is still an American spacecraft, 1 pound, sent into orbit once cost nearly $39,000. Today it costs $1,755. Now, does that mean you can arrive at Cape Canaveral with a suitcase, $1,700, and a willingness to hold your breath? Not really. I mean, these are just average payload costs, not passenger fares. Humans, we require seats, life support, abort systems, food, water, and at least one person whose job is apparently to remind everyone not to open the door. Now, even with these qualifications, a 96% reduction is enormous. Now, I think more importantly, the researchers found that the decline was not random. Every time the total amount of payload launched throughout the history of the industry doubled, the average cost of reaching orbit fell by another 21.2%. In other words, spaceflight appears to follow the same basic rule as most other technologies. The more often you do it, the better we become at doing it. Take that as a double entendre if you wish. I mean, we have factories improving, designs are being refined, procedures stop being invented from scratch for every mission. Engineers discover which parts need to be stronger and which part needs to, needs maybe to be expensive in the first place. For rockets, the learning process has been usually fast. According to the study, launch technology has improved more rapidly than solar panels, a technology frequently held up as the modern standard for falling cost. It even outpaced the historic improvement in steamship freight. Now, rockets are still dangerous, temperamental machines filled with, basically barely controlled explosions. We have simply become remarkably good at manufacturing those explosions on a schedule. The first major decline occurred during the space race. The United States and the Soviet Union were launching often, experimenting constantly, and pouring more national resources into the effort than one can imagine. Costs fell sharply through the 60s and the early 70s. Then Apollo ended. Saturn V disappeared, launch costs stopped improving, and even rose slightly before remaining relatively stable for nearly 2 decades. The decline actually began in the 1990s as commercial spaceflight expanded. But, of course, the researchers found another noticeable acceleration after, no surprise here, the Falcon 9 entered service and reusable boosters began flying at scale. There is an important difference between building a magnificent rocket and building one you can fly repeatedly. Saturn V may remain one of the most impressive machines humanity has ever constructed, which is debatable, but let's say so. But every launch required another Saturn V. The rocket performed its mission brilliantly and then distributed itself across the ocean. Falcon 9 has changed the economics because its most expensive portion could return, land, and undergo inspection, and then fly again, and again, and again, and then again, and again. It transformed part of the rocket from ammunition into equipment. Now, SpaceX did not invent the idea of a reusable launch vehicle. No matter how enthusiastic the company's fan club became, after 3 minutes on social media, NASA had flown reusable space shuttles for 30 years. Technically, this counts. The shuttle, however, required an enormous amount of work between missions and never achieved the airline-like turnaround its designers had imagined. Now, SpaceX made booster reuse frequent enough to become, routine. The difference is now visible across the launch industry. Rocket Lab is developing Neutron around reusability. Japan recently launched and landed a small experimental reusable rocket. China is pursuing, stealing, reusable systems of its own. Even the enormous Starship is built around the idea that nearly the entire vehicle should return and fly again. Whether every one of these vehicles succeeds is almost beside the point. The industry has accepted the underlying argument. Throwing away a rocket after every flight is becoming as economically ridiculous as throwing away an airplane after it lands. Now, if the current learning curve continues, the study projects that an average launch could cost, the fall could cost to $1,600 per kilogram by 2030, and by 2040 it could reach $300 per kilogram. Now, once again, because we like dealing in freedom units, that would be approximately $136 per pound. Sending a 16-pound bowling ball into orbit would cost a little over $2,000. Now, before purchasing the bowling ball, of course, building the spacecraft, obtaining regulatory approval, and explaining to the world why humanity needed an orbital bowling ball, but someone eventually will do it. They will. Just going to happen. But at those prices, entirely different missions become possible. Space telescopes would no longer need to spend decades fighting for a budget of a small nation. Replacement satellites could be launched instead of designed to survive forever. Materials, fuels, tools, and medical equipment could move into orbit in quantities that once would have been absurd. Now, cheaper access does not merely allow us to launch more of those things we already have. It changes what becomes reasonable to build. And that is the point where rockets stop being isolated spectacles and start becoming, dare we say, transportation infrastructure. Airplanes changed the world when flight stopped being a daring exhibition and became a way to move people and cargo. Railroads changed nations when individual tracks joined into networks. Spaceflight is approaching a similar transition. We are no longer discussing a handful of heroic expeditions separated by years. We are kind of discussing traffic. And with traffic, it brings opportunity. Now, it does also bring congestion, accidents, advertisements, military contracts, corporate control, and some idiot who is absolutely going to launch a billboard large enough to be seen from Earth. But the falling cost curve is also not guaranteed to continue. Orbital debris is already traveling around Earth at roughly 17,000 miles per hour. Increasing the number of launches without improving how we manage dead satellites and discarded hardware could eventually make useful orbits more dangerous and more expensive to reach. Now, competition presents another problem. SpaceX currently carries roughly 3/4 of the total payload launched worldwide. The dominance helped drive cost downward, but dependence on one company gives the company enormous power over prices and access. Geopolitical tensions could slow progress as well. Governments do not like depending on another nation or another nation's private company for access to orbit. Countries may choose to maintain independent launch systems even when those rockets cost more, because the cheapest ride is not particularly useful when the owner refuses to let you aboard. Now, a 96% drop in cost, therefore, does not promise a future in which space becomes cheap, peaceful, or even fair. It does tell us that something fundamentally has already changed. Humanity spent decades proving that we could reach space. We are now learning how to keep going back without treating every launch like the construction of a new pyramid. And over the coming years, the most important rocket may not be the largest, the loudest, or the one surrounded by the most aggressive online fan base. It may be the vehicle that flies so reliably and so affordably that most people stop paying attention. Because once rockets become ordinary, the things they carry no longer have to be extraordinary just to justify the trip. More satellites, more science, more people, more possibilities. And, of course, the undoubtedly increase of stupidity. Humanity spent decades proving we could reach space. Now we are learning how to make getting there a little more routine. And let's not forget, cheaper access to orbit changes what becomes possible. And apparently, the United States Space Force has decided to test that theory using the national credit card. The Space Force has tripled the maximum value of one of its primary launch contracts from $5.6 billion with a B dollars to $17 billion with a B dollars. Combined with a separate $13.7 billion contract for more demanding missions, the military can now purchase more than $30 billion in launch services. Now, before anyone imagines a Guardian walking into SpaceX with a $30 billion check, because, well, let's face it, that's not how any of this works. But in bureaucratic terms, the Space Force has dramatically increased the limit on its shopping cart, but it's not checked out yet. Even so, the size of the shopping cart reveals how quickly military activity in orbit is expected to grow. When the current program was established in 2024, the Space Force anticipated ordering approximately 60 launchers through what it calls Lane 1. Now, that has increased to 170 launches between 2025 and 2034. Lane 1 is the commercial-style side of the program. It's carrier satellites that can accept slightly more risk, allowing faster integration and less government oversight. That does not mean the military is casually strapping classified hardware onto whatever rocket happens to be parked nearby. It just simply means these missions do not require every layer of protection reserved for the government's most expensive and sensitive spacecraft. Those missions go through Lane 2. Lane 2 includes advanced GPS satellites, military communication systems, and classified spacecraft belonging to the National Reconnaissance Office. The military initially planned 54 of those missions, and it is already considering 25 more. Add that to Lane 1, and the United States could conduct more than 200 national security launches within roughly, a decade. That is not an occasional government rocket launch. Once again, basis of the theme so far, that's traffic. Now, much of the demand comes from a change in how military space systems are being designed. Instead of depending on, a few enormous satellites that cost billions and billions of dollars and taking years to replace, the Space Force is building network-contained hundreds or even eventually thousands of smaller spacecraft. Those satellites will watch missile launches, track moving targets, carry military data, and observe activity through Earth's orbit. The larger network is harder for an enemy to disable with just a single attack. If one satellite fails, the entire capability does not disappear with it. Damaged or outdated spacecraft can also be replaced more quickly, assuming, of course, enough rockets are available to launch. 7 companies are eligible to compete for Lane 1 missions. Alongside SpaceX, United Launch Alliance, and Blue Origin are newer vehicles being developed by Rocket Lab, Stoke Space, Relativity, and Impulse Space. At least that is the current plan. Several of those companies have not yet flown the rockets they intend to offer. Putting 7 names on a contract creates potential competition. Real competition, though, begins when those rockets actually reach orbit. Now, for now, SpaceX, of course, has received most of the work already awarded. If the government wants a launch market instead of another near monopoly, those newer vehicles have to succeed. Now, there are larger questions hiding behind the procurement language. Thousands of military satellites mean greater surveillance, congestion, and another reason for rival nations to treat space as a potential battlefield. It also means the United States believes access to orbit has become dependable enough to build a military strategy around it. And this may be perhaps the clearest evidence that rockets are becoming infrastructure. The Space Force is no longer planning around just a few, my precious, launches. It's now kind of reserving an entire highway's worth. Of course, reviving the highway, or reserving the highway only works if someone can build enough vehicles to fill it. And that company currently carrying most of the traffic has just, in case you haven't been paying attention, flown the largest rocket ever constructed. Again, that company is, of course, SpaceX. On July 24th, Starship Flight 13 lifted off from South Texas. The 407-foot-tall rocket was flying only the second test of its updated version 3 design. And unlike Flight 12, this one gave SpaceX considerably more to celebrate. The launch itself went cleanly. Super Heavy separated from the Starship upper stage, performed its flip, and began returning toward the Gulf of Mexico. Well, okay, it wasn't all celebration because it did meet some reality. 13 engines were supposed to ignite for the booster's initial landing burn. Only 5 did. Super Heavy came down with far too much speed, hit the water hard, and the video feed disappeared almost instantaneously. So when you hear Flight 13 described as a complete triumph, remember that, half of the largest rocket, a little more than half of the largest rocket ever built, essentially, belly flopped into the Gulf of Mexico like a fat dude. That said, the upper stage, had an excellent flight. Starship was able to deploy 20 test versions of SpaceX's next-generation Starlink satellites. Now, these were not destined to remain in orbit. The mission followed a suborbital path, so all 20 eventually re-entered and burned up as planned, but their job was to prove the Starship could release real hardware through its unusually slot-shaped payload door. That system worked. Starship then restarted one of the Raptor engines in space, and look, I know that may not look or sound as dramatic as a launch or landing, but it is quite essential. A spacecraft designed to enter orbit, leave orbit, travel to the moon, or eventually go anywhere else needed needs to be able to shut its engines down and reliably start them again. Of course, then, we have to deal with re-entry. Camera showed Starship wrapped in plasma as it passed through the atmosphere. The vehicle remained under control, flipped upright over the Indian Ocean, and performed the softest splashdown of any Starship so far. It was so gentle that the ship remained intact, tipped onto its side, and floated on the surface while continuing to transmit data. For a test vehicle that has developed something of a reputation for ending its flights as, how do I put this? Expanding cloud of stainless steel, this was tremendous progress. It is also not the same as having a fully operational rocket. Let's keep that in mind. But after 13 test flights, Starship still has not completed a full orbit of Earth. Let's not forget, SpaceX must demonstrate orbital refueling, return an upper stage to land, prove that both stages can be reused, and develop the life support systems required for astronauts. NASA is depending upon a final version of the vehicle to land crews on the moon, so the remaining checklist is not optional. But Flight 13, therefore, deserves neither dismissal that some will do or the worship that others may do. It's somewhere in the middle. The booster failed its landing attempt. The ship, though, successfully deployed payloads, restarted an engine, survived re-entry, and touched the ocean with remarkable control, to the point Elon is hinting that they might try to catch the upper stage next time. So as humans prepare to travel farther from Earth, launching them is only the first problem. We cannot forget that keeping them alive when something breaks is another important aspect to take a look at. And for more than 40 years, ultrasound has been the only reliable medical imaging technology available in space. Now, ultrasound is an extraordinary tool, but it requires training, careful positioning, and a relatively skilled operator who knows what they are looking for. An astronaut halfway to the moon cannot simply be loaded into an ambulance and sent to Houston. During the private Fram 2 mission in 2025, researchers tested another option: a portable, commercially available X-ray machine. Nothing aboard the spacecraft was a massive, custom-built laboratory. The system was small, battery-powered, and similar to portable machines already used at sporting events and the remote communities. The participating crew members were not radiologists or X-ray technicians. They received only 4 hours of training before launch. Once in orbit, they produced X-rays of a hand, forearm, chest, abdomen, and pelvis. They also imaged a smartwatch to determine whether the machine could inspect equipment as well as people. Let's not lose sight of this. These were the first diagnostic human X-rays ever taken in space. The largest problem was not radiation or image quality. It was getting everything to hold still. Testing an X-ray is difficult when the patient, the detector, and the person holding the machine are all attempting to float in different directions. The crew recommended adding better clamps and mounting points, which sounds obvious until you remember that portable X-ray machines were designed for hospitals where the floors generally stayed beneath you. Back on Earth, 3 independent radiologists compared the orbital image with X-rays taken before the flight. The positioning of the chest, abdomen, and pelvis were not quite as precise in space, but every image was considered good enough for diagnosis. The machine also survived launch, orbit, re-entry, and recovery with only superficial damage. For crews traveling to the moon or Mars or further, this could be enormously important. A portable X-ray could help diagnose broken bones or internal problems when evacuation is impossible. It could also examine damaged space suits, electronics, or spacecraft components without taking them apart. The same technology could be useful in rural clinics and disaster areas here on Earth, where access to a hospital may be hours away. Normally, we talk about inventions created for space eventually finding uses on Earth. This time, researchers took an existing Earth technology, launched it into orbit, and proved that it could work there too. Humans, officially now, can take useful medical x-rays in space. Which is kind of reassuring because for all of this brilliance, we have also, for some reason, begun decorating rockets with energy drink advertisements. And yes, it's time.
And now, Assholes in Space!
China is asshole! China is asshole! China is asshole! China is asshole!
Never get tired of that song. So on July 14th, a Soyuz rocket left Kazakhstan carrying 3 astronauts to the ISS. The mission was mostly routine. The rocket was not. And let's remember that all assholes in space are not Chinese. There are sometimes a few other countries that invade this segment. Painted across its side of the Soyuz rocket was an advert for Lit Energy Lemonade. Because apparently a vehicle carrying human beings through several controlled explosions needed the reassuring image of something purchased beside the beef jerky at a gas station. I wish I was making that up, but I'm not. Now, granted, the Soyuz also carried artwork created by children with cancer for a charitable foundation, along with the phrase, "Life has no end." That part is genuinely lovely. The energy drink logo is Russia re-enters the conversation. Because a Russia law that took effect in January now permits advertising on state-owned space hardware. The goal is for attracting private money and reducing government cost, which sounds better than admitting sanctions have reached a point where even the rockets now need sponsors. Now, is this new? No. Because how many have forgotten this next part? Russia has decorated rockets before, including a Pizza Hut advertisement in 2000. Now, admittedly, it's ridiculous, okay? No other way to put it. But pizza actually does become at least a little useful after launch. An energy drink aboard a rocket kind of feels redundant because if you're not full of energy with that many pounds of explosives strapped beneath your nuts, are you even alive? I don't think caffeine's going to help you after a rocket launch. I'm just saying. But lest you think this segment is nothing but Russia, we do actually have a little bit of a story from China. They found another way to make a routine launch a little more dramatic. For on July 23rd, a Long March 3B lifted off from the Xichang Satellite Launch Center, and about 30 seconds later, it was struck by lightning. Now, that said, the rocket kept flying and successfully delivered a communication relay satellite into orbit for China's Xinyang space station. Now, the rocket itself may have triggered the strike. Its exhaust can leave an electricity conductive trail through the atmosphere, creating a very easy path for lightning to follow, which is why weather is monitored carefully at all levels of the atmosphere for American launches. But the Long March did survive. The satellite did reach orbit. So technically the mission is declared a success. So it was also, rocket flying through lightning while Russia launched a crew inside a traveling energy drink advertisement. Humanity is making spaceflight routine in the most human way imaginable, recklessly, commercially, and with excellent logo placement. Now, on that note, we are going to step away for a few minutes. I appreciate anyone who is listening. Feel free to stop in the chat. I'm feeling a little lonely tonight. That said, we're going to step away for a few minutes. And this is called You Only Looked Back.
You decided I was distant before you ever walked away. You made me something smaller, so leaving felt okay. I wore the dress you always loved and waited where we used to meet. I learned the names of all your friends and crossed your shadow in the streets. I left the porch light burning late. I let your records fill the room. I tried to make you miss the girl you buried underneath the truth. I changed the way I wore my hair. I found somebody you would hate. I laughed too loudly when you passed and stayed outside a little late. I sent a message, took it back, then swore I wouldn't try again. But every little move I made was one more way to pull you in. You only looked back when the ground gave way. When everything you left behind came down in a day. You only said my name when the silence cracked. You never saw me standing there. You only looked back. And something underneath me moved too deep for either one to see. The weight of everything I kept came tearing loose inside of me. No warning sign, no final word, no careful way to save the past. The life I built around your ghost was never gonna hold at last. Now all the rooms are empty space, the pictures buried in the dust. You stand outside and call my name, like hearing you could still be enough. You say you never meant to leave, you say you finally understand, but you only came to find me when there was nothing left to stand. You only
and welcome back aboard the ACS Serenade. We only looked back for a few minutes. Pluto, meanwhile, has apparently, while we weren't looking, been rearranging the furniture on us. Now, before we go any further, as is the way of the Lost Wanderer podcast and me, JEFF, hosting it, Pluto is a planet. The International Astronomical Union can send its complaints to the frickin' airlock. Now, more than 11 years after New Horizons flew past Pluto, scientists are still finding things in the images it sent home. A new analysis has identified the first confirmed landslides on Pluto. Matter of fact, researchers found 6 of them inside 3 craters alongside the western edge of Sputnik Planitia, the enormous heart-shaped plain that dominates Pluto's surface. New Horizons' long-range camera revealed bumpy aprons of ice and debris spilled down the crater's inner walls. The largest slide dropped roughly 1.4 miles and left debris stretching nearly 9 miles across the crater floor. That is a moving field of ice large enough to cover a city. Now, because Pluto's gravity is only 6% of Earth's, these ice landslides traveled unusually far compared with their fall. Scientists do not know whether the low gravity, the icy material, or perhaps embracing the power of Anne, even though he's not here listening to the show because he's dealing with wildfires in California. Thank you, Orty, for everything you do over there. Made them so mobile. They are also unsure what started them. One slide inside Coughlin Crater may have been triggered by a nearby impact. Others could be connected to Pluto's extreme seasons as surface ices turn into gas and later freeze again, possibly weakening some of the steeper slopes. Now, no one watched the slides happen. They are evidence of Pluto's surface continues changing over geological time. But then, James Webb Space Telescope found something even stranger. When researchers examined infrared observations of Pluto, they found that its surface absorbs light at a wavelength of precisely 5.113 micrometers, or micrometers, whatever you want to call it. Every molecule absorbs light differently, creating a chemical fingerprint. The problem is the scientists cannot identify the molecule that left this one. Now, before you think it's a one-off, they had already found the same fingerprint on Titan, Saturn's largest moon. Titan and Pluto both have nitrogen and methane chemistry, but Titan's thick atmosphere is roughly 100,000 times denser than Pluto's. Yet both carry the same unidentified signature. Webb detected it on Titan with 2 separate instruments, then found it on Pluto at exactly the same wavelength, making an equipment error extremely unlikely. The feature on Pluto is about 3 times broader and roughly twice the overall strength, suggesting the same compound or chemical family may exist in a different mixture or physical form. Scientists compared it with laboratory spectra for acetylene, benzene mixtures and found compounds called alans. Speaking of Alan, where are you? Come back, we need you. Each offer clues. None provided a complete match. Now, I know, no, don't, Avi, I know you're out there. Don't go here. This is not evidence of alien life. You don't have to write a paper on this. We're good, okay? We're good. It is evidence that complex chemistry driven by sunlight and radiation may produce the same unknown material on 2 very different worlds. Basically, Webb found fingerprints. And, well, right now, the suspect is kind of refusing to identify itself. This is why Pluto refuses to become irrelevant. Every time someone dismisses it as a frozen piece of debris, Pluto answers with moving glaciers, blue haze, mountains of water ice, enormous landslides, and chemistry we cannot explain. The little planet did not stop being a planet because the committee got Neil deGrasse Tyson. It simply kept doing geology while they argued. And let's face it, of course, Pluto has one advantage. Humans have not landed there yet. But the moon, well, the moon is really, really going to lose that advantage here soon. Because NASA and several private companies are preparing to return people and cargo to the lunar surface, with much of that activity aimed toward the southern pole. That location was not chosen merely because everyone enjoys parking in the same neighborhood, though. God, why do they always go to the same store you are when you haven't been there in 6 months? And every time we drove past it those 6 prior months, there was no one there. But the day you decide to go there, everyone else decides. What's up with that? Back to the story. Deep craters near both lunar poles remain permanently shadowed. Some have not had sunlight for billions of years, allowing water, ice, and other frozen compounds to survive almost completely undisturbed. So yes, certain Disney mermaid movie got the lyrics right. Baby, it's better down where it's wetter. This applies apparently to the moon. Now, mixed into that ice may be some organic material delivered by ancient asteroids or comets, and including prebiotic molecules, the chemical ingredients that maybe, ingredients that existed before life. Earth probably once held a similar record, but weather, oceans, plate tectonics, and life itself have rewritten most of it. The moon never became geologically busy enough to destroy its copies. Now, unfortunately, the engines delivering scientists to that archive may contaminate it. I know I'm going to sound like a hippie on this, but this is more science. They may contaminate some of the findings. But a recent study modeled the European Space Agency's Argonaut lander, which propellants produce methane during combustion. Researchers began their simulation roughly 19 miles above the lunar south pole and tracked where the exhaust traveled after descent. Without an atmosphere to contain or disperse it, methane does not remain politely near the landing pad. Individual molecules, they follow ballistic paths, hopping across the surface as sunlight warms them and frees them into place when they reach the colder regions. In the simulation, methane reached the moon's north pole in less than 2 lunar days, roughly 2 months on Earth. After 7 lunar days, or nearly 7 Earth months, more than half of it had become trapped in the moon's polar cold regions, and about 42% accumulated near the south pole, while another 12% reached the north. In other words, exhaust from one landing site could eventually place modern organic molecules inside the same frozen archive scientists hope to examine for ancient ones. Now, that does not mean one spacecraft landing will erase the moon's history. This was, after all, just a computer simulation, and let's face it, scientists' computer simulations when it comes to climate and things like this have not been stellar over the years. But it is a possibility we have to examine. This is why they want instruments aboard early missions to measure what actually happens before the lunar traffic actually starts to become routine. It is important to note, for now, the argument is not that humans should stay away from the moon. We should absolutely go. But humanity is like the beavers of the world. It is remarkably good at arriving somewhere and immediately changing the thing we came to study or live in. If the moon may preserve evidence of how life's ingredients reached Earth, well, we need to consider it at the least. How do we avoid writing our own fingerprints over it before we have finished reading the book? And I think that is a fair argument. And if the moon contains an ancient record of what happened in our own solar system, worlds around other stars offer something else. The chance to learn how often the same ingredients appear elsewhere. And one of the most promising examples of this is LHS 1140b, approximately 48 light years away. The planet is about 1.7 times the radius of Earth and roughly 5.6 times as massive. It circles a cool red dwarf star every 25 days, but because the star produces far less heat than the sun, the planet actually remains within its habitable zone. And as always, habitable zone does not mean it is actually inhabited. It just means liquid water could potentially exist under the right atmospheric conditions. A house can be located in a residential zone without actually anyone, living there. Just look at Detroit. Scientists now have the strongest evidence yet that LHS 1140b possesses one of those necessary conditions, an atmosphere. Researchers observed the planet using the wine red spectrograph attached to the Magellan Clay Telescope in Chile. So we might have some evidence. So as LHS 1140b passed in front of the star, some of that starlight traveled through the planet's upper atmosphere before reaching Earth. Mixed into that light was the unmistakable signature of helium escaping into space. Another planet in the same system, LHS 1140c, crossed the star during the same night but produced no helium signal. That gave researchers an extremely useful comparison and helped confirm that the helium was indeed coming from the B model. Now, the signal appeared during observations in 2024 but was not detected again in 2025. And researchers believe the planet's atmospheric escape may change as ultraviolet radiation from its star waves and rises and falls and all of that. That does not mean the entire atmosphere disappeared within a year. It just means the helium leaking from its upper layers just wasn't equally visible during both of the observations. And models suggest hydrogen may have escaped from the planet long ago, leaving its upper atmosphere rich in helium, while heavier gases remain trapped closer to the surface. This is significant because red dwarfs frequently blast nearby planets with radiation capable of stripping their atmospheres away. LHS 1140b star is approximately 6 billion years old, suggesting the planet has protected at least some atmosphere, potentially for billions of years. Now, for the portion that will disappoint several headlines and probably Avi Loeb, though he'll probably disagree with it, scientists have not discovered life. They have not confirmed oceans, breathable air, vegetation, or helium-breathing aliens with exceptionally squeaky voices. They'd probably sound like this all day long, and you'd want to kill them and invade them, and yeah. But what they have found is a solid planet, possibly containing enormous amounts of water at a temperature where liquid water could exist, with direct evidence that an atmosphere survives around it. That combination makes LHS 1140b one of the best places we know to continue looking. It's also large enough to hold onto all of the surface, suitable temperatures and atmosphere capable of helping with life. Which raises the next question: how small can a potentially inhabited planet actually be? Something we really haven't discussed at all in all the years we've done this show. Now, it has to be large enough to hold onto all of the surface and suitable temperatures, atmosphere, and all of that. So, according to a new computer model, small in planetary terms may still mean roughly 6,300 miles around. Researchers created something that they're calling the Smaller Than Earth Habitability Model, or STEM with an H. We need better naming protocols to stimulate rocky worlds ranging from half the size of Earth to Earth size. The model follows a battle between gases escaping into space and volcanoes releasing new gas from inside the planet. Under Earth-like starting conditions, a world needed to be at least 80% as wide as Earth to maintain an atmosphere for billions of years. Anything smaller tended to show that they lost gas faster than its interior could actually replace it. This happens for two reasons. A smaller planet has typically weaker gravity, making it easier for radiation and stellar wind to carry atmospheric gases away. Its interior also cools a bit faster. As the mantle cools, the outer rock thickens, volcano activity declines, and the supply of replacement gas kind of begins getting shut down like it's in the Strait of Hormuz. An atmosphere, it turns out, is not something a planet simply acquires and keeps. It is more like a roof that is constantly leaking, while volcanoes serve as an extremely slow repair crew. We've all had to deal with them in the past. And about 80% of Earth's width, a planet could keep the crew working long enough. Mars, for comparison, is only about 53% as wide as Earth, and we've already seen what happens when a small world loses that fight. Now, there are exceptions to the rule, because of course there are. A smaller planet born with far more carbon in its mantle could produce enough heavy carbon dioxide to hold on to its atmosphere. Yes, you're hearing me right. Carbon dioxide is good for the atmosphere. A thicker mantle, more heat-producing radioactive elements, or an unusually cool beginning could also help with this. Now, this last one sounds backward because thinking cooler young planet may delay its volcano activity until its star has finished throwing most of its violet tantrums. But instead of releasing gases just in time for them to be blasted into space, it kind of saves them until the neighborhood settles down. Under those unusually favorable conditions, a world between 60 and 70% of Earth might maintain or eventually rebuild an atmosphere. This does not prove every small planet is sterile. This model just examined a specific kind of rocky world around a sun-like star, and underground life would not necessarily care whether the surface has pleasant weather at all. Its real value is more of a triage. Astronomers have thousands of exoplanets and limited telescope time. The habitable zone tells us whether a planet has the right address. STEM, with an H, asks whether the house still has any walls or a roof left. And even when that roof is gone, material falling from space may actually help build it again. It's crazy how the universe does this, and we never give it credit or the possibility that it does it. Because here, closer to home, astronomers have uncovered a hidden population of debris in geosynchronous orbit roughly 22,400 miles above Earth. This region includes the geostationary belt, where satellites circle Earth once every 24 hours and appear to remain over the same location. That makes it exceptionally valuable for television, communications, weather forecasting, and surveillance. It also makes it available, orbital slot prime real estate. But the researchers from the University of Warwick re-examined old observations taken with the Isaac Newton telescope in the Canary Islands. They processed the image using a technique called blind stacking. The computer tested possible paths an object might follow and combined the images along each one. A fragment lost in the noise of a single frame becomes visible when its faint light repeatedly lines up. The team found 25 debris tracks missed during the original analysis. When all the faint objects in the study were counted, nearly 80% did not appear in public catalogs. Some fragments, they may only be 2 inches across. And I feel your pain, brothers. Feel your pain. And the free space junk makes this sound borderline harmless, borderline not. As though someone dropped a sandwich wrapper behind the moon and got caught there. But we have to keep remembering at several kilometers per second, a 2-inch fragment is not litter. It is and should be considered a projectile. That is a particularly dangerous and geostationary orbit where satellites can carry solar arrays stretching 100 feet or more. Now, a fragment does not need to destroy the entire spacecraft. Damaging its power system, antenna, or instruments may be enough to end the mission. Debris in low Earth orbit encounters traces of atmosphere that can gradually pull it down. At geostationary altitude, there's basically no atmospheric drag. God, can you imagine living in a place with no drag? Take whatever meaning you want of that, Mr. Frodo. Once junk reaches that region, it can remain there basically indefinitely. Every collision, explosion, and abandoned piece of hardware therefore adds to a problem nature is not going to clean up for us. The good news, though, is improved software can uncover objects hidden inside observations we've already processed. The bad news is that those objects were already there, moving along some of humanity's most valuable spacecraft, while most remained absent from public catalogs. As we say on this show repeatedly, space is enormous, but the useful lanes around Earth are not. And once again, going to sound a little bit hippie-ish here, it might be time before we add more traffic that maybe we should spend a little bit of time and money on better surveys, responsible, retirement plans, and, the apparently radical idea that whatever creates the mess should probably help clean it up. Looking at you, Russia. Looking at you, China. But for now, let's turn away from the junk we place in the sky and look toward what nature put there. Normally, we'll see if I can get through this. This is where I would say it is time for Stargazer. But not tonight. Yes, the Perseid meteor shower is already underway, and it will reach its peak during the night of August 12th and the morning of August 13th. And Earth will pass through a trail of debris left behind by Comet Swift-Tuttle. Tiny pieces of dust will strike our atmosphere at nearly 37 miles per second, creating some of the brightest and most beautiful meteors of the year. And the moon will nearly be invisible that night. Under dark skies, observers may see dozens of meteors per shower. It should actually be quite a spectacular show. And on May 8th, 2020, another show began. Tonight, that show reached episode 132. All 132 of those episodes were made with my son helping me. COVID had closed the schools like millions of parents. I suddenly needed to find a way to educate him. My solution was apparently to start a space podcast. What began as an attempt to keep him learning became the Lost Wanderer. He became the show's executive producer. He helped choose stories, approved or rejected some jokes, gave songs a thumbs up or thumbs down, and listened as I tried to explain black holes, distant planets, exploding rockets, and whatever ridiculous thing Elon Musk had done that week. He helped make this. Tonight is the final episode he will be helping me with. After more than 6 years and 132 episodes, the kid I wanted to educate during a global pandemic is leaving for college. Leaving for college to study nuclear engineering, which feels like a rather aggressive way to prove that maybe my experiment worked a little. I am proud of him. I'm excited for everything awaiting him. I'm going to miss him. He will only be 2 hours away. I know that's not an enormous distance measured across the Earth or the universe. But any parent knows it's not measured in miles. The show will continue. Stories will still arrive. Rockets will launch. Scientists will discover things we barely understand. Pluto, of course, will remain a planet, and someone will inevitably do something stupid enough to earn a place in assholes in space. But it will be different. The person who helped give the show its voice will no longer be sitting nearby. Love you.
The universe is a pretty big place. If it's just us, seems like an awful waste of space. And space is big, really big.